In this problem, we're going to look at how we can use conservation of mass to help us determine the empirical formula. So this problem says 1.56 grams of copper reacts with oxygen in the air to form 1.95 grams of copper oxide. Calculate the empirical formula of the copper oxide. So remember, when I say copper oxide, copper can form two different types of charges. It can form Cu plus or Cu2 plus. So actually, if I say copper oxide, I'm not sure. Do I mean copper 1 or copper 2? I could have Cu2O or CuO as potential chemical formulas. So just telling me that doesn't help. But they do tell me that they reacted copper with the oxygen in the air and they measured the mass of their product. And so we can use that to help figure out the empirical formula. So I know that I'm reacting copper with oxygen in the air, which is O2, elemental oxygen, and I'm making copper oxide with a formula that I don't know. And there's 1.56 grams of the copper, and I measured the mass of my product, and that was 1.95 grams. I don't know how much oxygen from the air reacted because I can't measure that, but I can figure it out using conservation of mass. So I know that 1.56 has to add to something to give me 1.95. So if I subtract 1.95 minus 1.56, I get 0.390 grams of oxygen. Now that I know how much copper I have and how much oxygen I have, I can figure out my empirical formula. So I need to take both of the elements that are in my compound and convert it into moles so I can look at the mole ratio. So I had 1.56 grams of copper. I want to figure out how many moles that is. The molar mass of copper is 63.55 grams per mole. So if I divide 1.56 by 63.55, I get 0.0245 moles of copper. So now I want to look at oxygen. I decided I had 0.390 grams of O2, and oxygen is approximately 32 grams per mole, but that is O2, and I want to look at just the oxygen, a single O that might be in my compound. So for every 1 mole of O2, I have 2 moles of oxygen. So if I multiply 0.390 by 2 and then divide by 32, I get 0.0244 moles of oxygen. Now, if I look at these two numbers, they're essentially the same. So I essentially have a 1-to-1 ratio, but I can divide by the smallest number just so that I can be sure. So I had 0.0245 moles of copper and 0.0244 moles of oxygen. If I divide by the smallest number, that's 0.0244. So if I divide for copper, 0.0245 divided by 0.0244, I get 1.004. That's very, very close to 1, so I can round that to 1. So that means I have 1 copper and 1 oxygen. So that means that I had copper 2 plus, and so this is copper 2 oxide.